Again, in this video, we're going to be looking at differentiating just a few more equations. I know it's quite a lot, but it's to make sure we've covered the majority of possibilities, and it is a very important topic. So starting with part H, just continuing on from the last video, again we know it must be put into index notation. So root x, remember, is x to the power of a half, and then we need to bring that up so it needs to become a minus a half. So y equals x to the power of minus a half, and again multiply down by the power, take one away from the power, so you'll get minus a half x to the power of minus 3 over 2. And once you do that, you can then rewrite it back using your rules of indices. So you've got minus 1 over 2x to the power of 3 over 2, which is the same thing as minus 1 over 2 square root x cubed. Part I, again, same thing, get it into index notation. So the x to the power of 4 you need to bring up to the numerator and change it to a power of minus 4. So y equals 4x minus 4 all over 3. If you prefer, you can write it as 4/3 x to the power of minus 4. It really doesn't matter, it's just whatever you find easier to work with. I just prefer to keep it as a fraction, but it's completely up to you. Once it's in index notation, then we can differentiate. So we multiply down by the power and we take one away from the power. So multiplying down by the power, we get minus 16x, take one away, minus 5 over 3. So remember, multiplying fractions, you have the 4/3 and you're going to multiply down by the power. So you're doing minus 4 times 4/3. Fractions, basic maths, numerator with numerator, denominator with denominator, which gives a minus 16 over 3. Again, then from here, we can tidy that up a bit if we want. So instead of leaving it as x to the power minus 5, I would bring that down to the denominator and write it as x to the power 5. So you have minus 16 over 3x to the... Okay, on to part J. So we're nearly finished. We've only 2 more to go. J, we've got 2 terms in our equation, so we're going to differentiate them individually, but looking at the second one we can see it's not in the right format, so if we put that into index notation first. So we've got y equals 8x to the power of 3 over 2, that didn't need change, minus 2x to the power of minus 1/3. So remember, cube root, you can write as a power of a third, bring it up to the numerator, needs to be a negative power. Now taking each one in turn, if you multiply down by the power and take one away from the power, being really careful with your fraction work it out, make sure you're getting exactly what I am. So dy by dx should be 12x to the power of a half, so 8 times 3 over 2 is 12. Remember, no calculator, so make sure you can do this in your heads. X to the power of a half, minus 2 times minus 1/3 becomes positive 2/3 x to the minus 4 over 3. And again, we can rewrite this. We can tidy it up a bit. So 12x to the power of a half. I'm just going to leave it the way it is. The question gave me it using powers, so I'm going to keep the power in my answer for now. The minus 4/3 I don't really like, so I'm going to bring that down to the denominator. So I have 2 over 3 x to the power of 4/3. So we can leave our answer like this, or if we prefer, we can put it in terms of thirds. But as the question used powers, for part of it anyway, I'm happy enough having powers. Okay, finally, on to the last part. In K, we've got y equals 2x minus 3 all squared. Now, for these types of questions, it is really important that we expand the bracket. So don't just multiply down by the power and take one away until you have expanded out that bracket. So rules for double brackets, multiply it out first, so you get y equals 4x squared minus 12x plus 9. And now take each term individually and differentiate those. Taking the first term then, so to get dy by dx, each term individually, the first term multiply down by the 2, so you get 8, and take 1 away from the power, you'll have a power of 1, which we don't need to write in. Second term, you're multiplying down by the power, which is a power of 1, so you've minus 12 times 1, which is minus 12. Taking 1 away from the power, you get a power of 0. And the last term, differentiating constant, you get a 0. So tidying that up, you can leave out this wee middle line here and go straight to the answer. You've 8x minus 12. Remember, anything to a power of 0 equals 1. So you just have 12 times 1, which is 12.